Hello everyone. In this particular video, I'm gonna covering end-to-end implementation of linked list with the help of Java programming language. Let's see what is our agenda for this particular video. In this particular video, we're gonna covering all the implementations related to the linked list, like insert at beginning, insert at end, insert at given position, delete at beginning, delete at end, delete at given position, search element, and traverse and print the linked list. So in a particular one video, we'll cover all these things. So this is gonna be a completely code specific video. I'm not gonna covering any theory part here. This will be like a complete code implementation of linked list. I have attached the timestamps as well in the description. You can check those as well, and you can move to any of the section. We will be covering total 7 scenarios. So without wasting any time, let's get started. By understanding how to create basic building block of a linked list, the node. So now we will be creating a node class. So let's create. This particular node class will be having two things. First is a first variable is node variable, node next. I will explain you what this variable is and what this particular variable does. And the second thing is int value. And we have to create a constructor for this node class. And this constructor will take input as an int value. And here we will set the values for the next variable as null, and for value variable as value. So let's understand what is this script is doing actually. So here we have a class named linked list. Inside it we have a nested static class called node, this one. This class is used to create each and every element or node of a linked list. So let's break it down. This particular node next. This means each node stores a reference to the next node in the linked list. It's how the all the elements are connected. So kind of like a chain. Okay. Then int value. Int value stores actual data in a node. Here we are using int, but you can use any data type like string, char, anything. Even generic also you can keep. Then this particular constructor. This constructor initializes a node. When we create a new node, we pass the value we want to store. The next pointer is set to null by default, because when a node is first created, it doesn't point to anything. That's why it is a node. So in next part, we'll see how we can actually add elements to the linked list. In this section, we will learn how to insert a node at the beginning of a linked list using Java. This is one of the basic operations and is very useful in both coding interviews and in real world applications. So let's give comment first. Insert at beginning. Okay, first we have to create a static node method, insert at beginning. Let's create one. We will create a return type as a node. And this method will take input as a node head. I will explain each and everything at the end. And one more variable we will need as a value. So here first what we will do, we will create a new node, new node is equal to new node. So basically we are creating object of this node class, and here we will pass the value. Once we create a new node, we will uh, assign next to this particular node as a head. So new node dot next is equal to head, and we have to return this new node. So at the end we'll return the new node. So let's understand what this particular line is supposed to be. Okay, so this insert at beginning, this is our method name. So this method name text in the head of the linked list and the value. So these two variables we are passing here. Then first we are creating a new node. Now we are creating this new node with the help of this value. Then as a second step, we are linking this new node to head. So we are setting up the next of the new node to point to the current head. This makes a new node comes before the existing list. And at the end, we are returning the new node. So since we have added new node at the beginning, this new node is now head of the list. Now once you print this linked list with the help of this new head, it will show you the element added at the beginning. So that's it for this section. In next section, we will first see how we can create a sample linked list, how we can print a linked list. In this section, we will learn how to print a linked list in Java. It is an essential step to visualize what's actually stored in your list. So let's start the code implementation. We'll give comment as a print linked list. Again, we will create a static method here. We don't need to return anything, so I'm just creating a void method here, and I will give name as a print linked list. Now as an argument, we will take node head. So now what we will do, first we will store the head of a linked list in a temp variable. So node temp is equal to head. So we are storing this incoming head into the temp. Now for the visibility, I will just give a sample print statement here, linked list. So this will help us to visualize the linked list more clearly. Now I will use a while loop to iterate through the all elements of a linked list. So we will iterate all the elements until the condition temp is not equal to null. If temp is not equal to null, we will go to the next node. That's the actual logic. I'm just adding one sout statement in between, and here we will print the value of each node, and then I'm just giving one space in between to so that it looks better. And at the end we will increment the temp pointer, so temp now will point to temp dot next. So this is how we will iterate through all the linked list, and at the end we will get all the values which are present in that linked list. So in previous sections we have covered insert at beginning and this node class. So let's create a main method and check whether our code is working or not. So first we will declare a head variable, node head is equal to null. So this will be just for implementation. Now we will insert an element at the beginning of a linked list. So let's call the method insert at beginning. Here we have to pass two values. First is head, and now I will pass element as a 9. I will do it couple of times. Okay, 3 times is fine. First I am inserting 9. Before 9 I am inserting 8, and before 8 I am inserting 7. And at the end we will print the list. We have to give head as a input. So once I execute this script, we will see linked list in a format like 7, 8 and 9, because every time we are inserting at the beginning. So let's run our program. So here you can see the linked list 7, 8 and 9. I just did one mistake. Instead of println, I just have to keep print here so that it will come in a single line. So here you can see we are able to print our linked list. So all the two previous methods like insert at beginning and the print linked list are working correctly fine. That's it for this particular section. In this section, we are gonna learn how to insert a node at the end of a linked list using Java. So we have already seen insert at the beginning. Now let's complete the other side of a list, insert at the end. So I will give name as insert at end. Now again we have to create a static method which will return node. This will be basically a head of a linked list which we are gonna return. Then we'll give name as a insert at end. Again we will need two arguments, node head of a linked list will need an int value. Now first let's create a new node. So node new node is equal to new node, object of a node class, and here we'll pass the value. Now once we have created a node, first we will check whether our head is null or not. If head is null, then there are no elements in the linked list, so we will directly return the newly created node. So for that we will write one if else condition. We will check whether head is equal to null or not. If head is equal to null, we will directly return the new node. Now if head is not equal to null, for that particular case, first we will store the value of head into the one temp variable, because we're gonna iterate through the linked list, so that's why we are keeping our head as a safe. Then we'll for iteration we'll use the while loop. In while loop we will navigate until the last node. So last node will be like temp next is not equal to null. So if temp not next is not equal to null means we came at the last node, and inside this we'll just increment the temp counter. Temp is equal to temp dot next, and once we reach to the last node, we will set the last node dot next to new node. So in temp we are having our last node, so last node dot next is equal to new node. So new node will be getting attached to the last node, and at the end we'll return the head. So with the help of this implementation, we'll be able to insert an element at the end of a linked list. So let's go again to the script one by one. So first we are creating a new node with the given value, and the next to set through the null by default. Here we are checking if the list is empty, then the new node become the first node of a node, and so we are returning the head directly. Now here we are traversing through the linked list. We are using a temporary pointer and keep moving until we are reaching the last node, and once we are reaching the last node, we are setting the last node dot next as a new node. So let's use this. So till now we have inserted 3 elements in our linked list, and we are printing the linked list. Now let's insert a few elements at the end. So I will give insert at instead of beginning we'll use insert at end. Again we have to give head, and second thing is value. I will pass 10 because, and one more thing we will pass 11 as well. So our newly created linked list will look like 7, 8, 9, 10, 11, and at then we'll print the linked list again. So let's execute our program. So here you can see our linked list implementation is correct. I will just give one more out statement here after this so that it should look good, right? So that's why that is fine. I will execute one more time. So Here you can see first we inserted 3 elements at the beginning of a linked list in the order 7, 8 and 9, and at the end we inserted 2 more elements at the end, 10 and 11. So all our functions are working correctly. That's it for this particular section. Section we are going to learn how to insert a node at a specific position in a linked list using Java. So this is super important for coding interviews because it combines traversal, insertion and boundary conditions all in one method. So let's get started. So first I will just give a comment as insert at given position. Again we'll create a same static method here as well, which will return node. Then I will give a method name as insert at given position, and here we will take 3 arguments. First is node head of a linked list. Second thing is int value. With the help of this value we'll create a new node. And third is int position, at what position we have to insert a particular element. So all the things will be the same like all other methods. First we will create a new node. So let's create a new node first. So when we will pass the value here, so this will create a new node which we're going to insert into the existing linked list. Next, the first condition is when we have to handle when the position is 0. Handle case when position is 0. So at 0's position, we have to handle the case. So first let's put one condition where we are checking whether position is 0. So at position 0, what we have to do, we have to put next node, new node dot next node is equal to head. So that position 0 nothing but we have to insert an element at the beginning of a linked list. So we have to keep new node dot next is equal to head, and we have to return the new node. So here we have handled if position is 0 means inserting an element at the beginning of the linked list. Same we have done here when we wrote the method where we are inserting at the beginning. The same thing we did here as well. So here we are inserting at the beginning. Next, now let's create a temp variable for temporary storage of head. We don't want node values to get changed because at the end we have to return node only. Then here we will create a for loop. For loop, our for loop will start from int I is equal to 0. Then it will go till int I is less than position -1. So we will go till position -1, and where temp is not equal to null, then I plus plus. I will explain you what this condition means actually in later on. Let's first finish the code and then I will explain. Then we have to just increment the temp pointer. Temp is equal to temp dot next. After that, first we have to check whether temp is null or not. Why we are checking this temp is null or not? Like we have to check whether we are at end of a linked list or not. That's why we are checking temp is equal to null. If we are at the end of a linked list, then just return head, that we can't move further than this. Then if we are not at the end of a linked list, then what we have to write, we have to write new node dot next. First we will save new node dot next is equal to temp dot next, because when we are inserting at the in between. Okay, and next thing we have to pass temp dot next is equal to new node. If you want theoretical video on this, let me know and at the end we'll return head. So now I will explain you what all these things are in a one by one way. So first we begin by creating a new node here. Then we are handling a special case here. If the given position is 0, that means we want to insert at the beginning. So we point the new nodes next to the current node and return the new node as a new head. That condition we have handled. Then we are traversing into the node just before the position. So if position is 6, then we have to stop at position 5, so that after 5 we have to insert an element, new element into the list as a next element. So we are using a loop to move temp to the node that comes right before the position where we want to insert. We also make sure we don't go out of the bounds by checking if temp is equal to null. Then second thing is, if position is invalid, suppose the particular position is not present in the linked list, we are just returning the head, we are not doing any insertions here. And at the end we are just inserting the new node here. And that's it for this particular video. Let's execute this insert at given position. So we will insert a new element, insert at given position. It will take head and the position head. Then we'll pass value as a 5 and we'll put this as a at second position. So let's execute the program. I think I missed something or what. Okay, I missed to print the list only. So we have to print the list at the end. So now it will work. So here you can see first we are having this linked list, and at position 2, this position 2, we have inserted 0, 1 and 2. At position 2 we have inserted 5. So this particular code block also working correctly. So that's it for this particular. So in this section we will learn how to delete the first node of a linked list in Java. Also it is known as deleting at the beginning. So let's start. So delete at beginning. Okay, first we'll create a static method which will return the head as a node. Then method name delete at beginning. We will need a head of a node here as an input. Now first what we'll do, first we will check whether head is null or not. If head is equal to null, if head is equal to null, then we will just return null as well. So there are no elements in the linked list, so no need to delete. Then if head is not null, then we will return head dot next, means next node of a head. So this will automatically delete the node pointer from head. So in this way we can delete any element from the beginning of a linked list. So let's use our method here, delete at beginning, and we'll pass head here. And now I will print the linked list again. Now it should delete the head of a linked list. So let's execute the program. Here you can see before deleting, the linked list was starting with 7, but we deleted one element from the beginning, so it deleted 7. Now linked list is starting from 8. So that's it for this particular section. We are going to learn how to delete the last node of a linked list with the help of Java programming language. This is a very common and important operation when working with linked lists. So let's start. Delete at end. So again we'll create a static method which will return head of a linked list. Delete at end. it will also take node head as an input. So first we have to check whether head is null or not, or head dot next is null or not. Head is null, nothing but the linked list is empty, no need to delete the end, just return the null. Or the head dot next is null, so there is only one element in the linked list, and if we delete the single element, there is nothing left in the linked list. So again we have to return null only. So in the if condition we have to write if head is equal to null, or head dot next is equal to null. So if both the conditions are true, then we have to just return null because there is nothing left in the linked list. Then we have to create a temp variable which will store our head as we are doing earlier as well. Then we have to use for a while loop to go to the second last node of a linked list. So we will traverse till temp dot next is not equal to null. If this condition is true, then we will increment the temp pointer. Temp is equal to temp dot next. And once we reach to the second last element of a node, we will set the next element of second last element as null. So this will delete the last node, and at the end we'll just return the head. So in this way we can delete a node from a end of a linked list. So let's explain the code. First, here we are checking if linked list is empty, then there is nothing to delete, we can just return null. And the second condition is we are checking whether there is only one node. If there is a one node, after deletion of one node, nothing left in the linked list, so we are just returning the null. Then again we are traversing till the last end here. So we are going till the second last node, and after second last node, the last node will be there. So last node we are marking as a null, so it will delete the last node. So let's check whether our code is working perfectly or not. Again, here I will call delete from end function, and we will give the head, so it should delete the end element from the linked list, and then we will again print the linked list. So let's execute. So here you can see before deleting the last node or the end of a linked list, the last element is 11. So after performing the operation deletion from end, it deleted the 11, and only now 4 elements are present in the linked list. So that's it for this section. So in this session, we are going to learn how to delete a node at a specific position from a linked list using Java. This is an important concept, especially for interviews where you will be tested on your understanding of a pointer manipulation. So let's get started. Delete at given position. And first we'll just create a static method here which will return the head of a linked list. Delete at given position, and here also we will need pointer to our head, and one more argument we will need, that end position, at what position we have to delete the particular node. So first thing is we have to check whether our linked list is empty or not, means head is equal to null or not. So we will check whether our linked list is equal to null. If it is a null, then we'll just return null because there is nothing to delete. So this particular operation is of no use at all. Then we will handle the condition for the position 0. Handle condition for position 0, where we have to delete the first node of an linked list. So for that we have to check if position is equal to 0. If position is equal to 0, means you are deleting the first node. Then what we have to return, you just return the head dot next. So it will delete the head node and will just return the next node of head. Now for the rest of the positions, first we have to store our head into one temp variable so that we do not change the values of node, so our linked list will remain intact. Then here again, as insert at a given position, we saw we used for loop instead of while loop. Here also we're gonna do the same. We will create a for loop here. Again we'll start with position 0, I is equal to 0, I is less than position minus 1, and I plus plus. And inside this for loop, first we'll check whether temp is equal to null or not, or temp dot next is equal to null or not. So if temp is equal to null, or temp dot next is equal to null. Here what we are doing, we are just checking whether current node is a null or not, or next of current node is null or not, because here we have to go to the second last node of a given position. So if my position is 3, then I have to reach till second position. So if this temp is equal to null, or temp dot next is equal to null, then we just simply have to return, no need to delete, because there is no element in the, or no position is left in the linked list. This will happen when the position is greater than the size of a linked list. Then if it is not the case, then we will just increment the temp pointer, temp is equal to temp dot next. And after that, once we reach to the previous node of a given position, then here what we will do, first again we will check whether temp dot next is not equal to null. If it is not equal to null, then only we will perform the insertion, and then we'll write temp dot next is equal to temp dot next. So what this will do, this will remove the temp dot next element. So temp dot next will become temp dot next, and at the end we just have to return the head. So this is how we can implement delete at a given position with the help of Java in linked list. Let's test our code. It will return head, and the method name is delete at a given position. So I will delete element at a position 2. So I will pass 2 here, and at the end we'll print the linked list. You have to pass head here. Now just execute the program. So here you can see, before deleting at a particular given position, the linked list was having 4 nodes, 8, 5, 9 and 10. After deleting the element which is at a 0 second position, like this is 0, 1 and 2, so we're supposed to delete 9, and here you can see we are successfully deleting 9 from the linked list. So this is how we can delete an element at a given position in Java from the linked list. So that's it for this particular section. In this section, we will learn how to search for a specific element in a linked list using Java. Searching is one of the most common operations, whether you are checking if a value exists or validating input in real-world applications. So let's see how we can write code for searching an element in a linked list or not. Here we will search an element whether present in a linked list or not. So we will return true if element is present, or will return false if element is not present. So let's start for search an element in linked list. So again we'll create a static method. Here right now we'll return boolean data type, because we just have to return whether it's present or not, true or false. So here we'll need 2 arguments. First is head of a linked list, and second thing int value, which we're gonna check whether present in a linked list or not. So first we'll check whether head is equal to null or not. If there is nothing in the linked list, then there is no possibility that this particular value is present in the linked list. So at that case we'll just return false, because there is no element in the linked list. If this condition is not true, then first we'll create a temp node, and we'll store value of head into the temp. Then we'll run the while loop. We will run the while loop until and unless the temp value becomes null. If temp value is not equal to null, then first we will check in the if else condition where temp dot value is matching with the value which we have entered or not. If it is matching, then we'll just return true, means the particular element is present in the linked list. If at this particular point this particular value is not matching, then we will just increase the pointer to the temp is equal to temp dot next, and at the end, if we didn't find any value which is equal to the value given or value provided, then at the end we'll just return false. So in this way we can write a method to search an element present in the linked list or not. So let's write a program now just call a method search element. We'll give head here, and we'll check what are the elements present in the linked list at the end of the operation. So there are 3 elements, 8, 5, 10. So I will use 5 here. We'll check whether 5 is present or not. And as you know, we have deleted 9, so we will search 9 as well, head comma 9. So both the things will search. Now what we are doing, we are not printing the result here. Okay, so what we'll do, I will just use one sout statement here, and I will just parse this value into a sout statement. So now it will print on the first line, it will print whether 5 is present or not, and second line will present 9 is present or not. So let's execute the program. So here you can see, first we are searching for 5 whether it is present or not. So we got output as a true because 5 is present in the linked list, and second 9 is not present in the linked list. That's why we are getting output as a false. So this is how you can search an element in a linked list. So till now, let's see what all operations we have covered. So from start, we covered how we can implement the node class. Then we start with the insert at beginning. Then we went to the how we can print the linked list. Then we saw how we can insert at end. Then insert at a given position. Insert delete at beginning, delete at end, delete at given position, and at the end we saw how we can search element in the linked list. So this was the end-to-end video of linked list implementation. In subsequent videos, I will cover the DSA questions as well related to the linked list. We will implement the double linked list as well, circular linked list as well. So make sure to like the video and subscribe to the channel for more such informative content. We will meet you in the next video.